All right, so this is going to be questions 25 through 28, okay? And we're going to do this mentally. So to do it mentally, sometimes you need to put it in a different form. So let's think about, because when it's in log base 2 of 1, how many of you think about numbers as logs? I mean, logs isn't very comfortable for you, right? But when we rewrite it, what's the base?
2.
2? To what power? Well, we don't know what the exponent is, right? That's the whole point. We don't know the exponent. That's why we throw it into the logarithm. So we can plug this into our calculator and figure it out. Right? Well, not yet, but I'll show you how to do that in a minute. But what number is it equal to?
1.
1. Okay? So then you ask yourself, 2 to what power is equal to 1? 2 to what power is equal to 1? 2 to the 1 is equal to 2. Remember the rule. We erase any
0.
number. Yes. There we go. I got it. Any number raised to 0 power is equal to 1. So if x were 0, 2 to the 0 is 1, right?
Yes.
There you go. X is 0. So it's mental math.
How does that even work? I thought
Anything, right? Remember, there's always a 1 out in front of a number, right?
Yeah.
So it's really 1 times 2. But when I write a 2 like this, I'm saying there's 1, 2 there, right? But if I were to say that there's no 2's there, right? There's no 2's there, then I would erase it, and what would be left?
1.
Ta-da! And that's why it's 1. Because there's no 2's. I'm here all week. Quit it. Alright, so we got this one. This is a hard one if you don't know what's going on. Right? But if you know what's going on, you know the rules of the game and play it better than everyone else. Right? That's the whole key, right? So, I need to know the rules of the game. Do you know the rules of this game? What's the square root of 4? 2. That was pretty easy. What's the cube root of 4? Or of 8? 2. Good. Right? Now, how did you figure out the 2 of them? How do you figure out the square root of 4? You say 2 times 2, right? Right? If I were to do 9, what would it be? 3. If I were to do 64, that would be 4. 4 times 4, so it's 4, right? Okay? But what are we doing? We're saying, oh, there's 3 4's, right?
Yeah.
Or there's 2 3's. But wait a minute, there's not a 2 here. How do you know that there's a 2 here? And you've just accepted that rule, right? That when there's no number, there's a 2 there. Does that make sense? You've accepted that rule. Well, there's a rule in logarithms. When there's no number, when there's no base, there's a 10 here. And the reason why we did that was so that we could compute them on the on this thing called the slide rule. Okay? And so they put base 10s on the slide rule. Now your calculators have this log function, right? And the log function says log. It doesn't say log base b. It says log, right? Because it does it automatically as a log base 10. Okay? So it always does the log base 10. So there's a rule that we use here. If we want to have a log of a number with a different base, then we divide that number of base 10 by the log of the base at base 10. And we call it log A over log B. And I like to call it slide in the line, draw in the log. Just keeps it simple. Okay? But it's a nice little rule to memorize. But what we need to know is whenever there's not a number there, there's a 10. Just like whenever there's not a number here, there's a 2. Does that make sense? Okay, so once I know that, it's easy. What's the base? What's the exponent? We have no idea, right? And what's the number? We said, 0.001. Now, isn't that 1/1000? Right? So what happened to this 10? It got flipped, right? So how many 10s multiply to get to 1,000? Can you tell me that much? How many 10s do you multiply to get to 1,000? So 10 times 10 is 100. So that's two 10s is 100. And if you multiply 100 by 10, you get 1,000. So how many 10s are there? 10 times 10, right, is 100. It's always hard for me. All right, 10 times 10 is 100. And then times 10 is 1,000. So there's 3. Okay? 3 10s. So in other words, this is 1/10 to the third, right? So x is 3, but it's a special 3. Right? X is a special 3. What happens? How do you make something flip? Negative. Negative exponents flip it. Okay? Negative exponents flip it. So that means that x is -3. Because what it's doing is it's flipping this. If it were 3, it'd be 10 to the 3, right? Which would be 1,000. But it's 1/1000. So it's flipping that 1,000 to be on the bottom. So therefore it has to be 10 to the -3. 10 to the -3 would drop that down to the bottom. See what I'm saying? So now it's 10 to the x is equal to 10 to the -3, which is equal to 1/1000. And there you go. That's all the work for that. Okay? Well, let's do one a little easier. How about, what's the base of this one? 4. Raised to unknown power is 64. So, how many 4s do I have to multiply to get 64? How many of these 4s equals 6? 4 times 4 is 16. 16 times 4 is? No, 16 times 2 is 32.
Oh, what did you say again?
16 times 4 is?
64?
Yeah. So there's 3 4s. Does that make sense? So then what's x? There's 3 4s. What's x? What's x?
3?
Yeah. X is 3. See the difference? This keeps it up top. The negative brings it down below. That's the difference. Okay? Alright, what about this one? What's the base? 0.1 raised to some unknown power is equal to 100. Alright, so in order to make that, can I just say that this is 1/10? Is that okay? So how do I put the 10 up top? How do I flip that? X has to be negative, right? And then that would be 1/10 in the top. But I need how many 10s to make 100? 2 10s, not 10 10s. 2 10s. So it's -2. Okay? How are we doing?